Okay, good morning to everybody. Today we'll discuss an important theorem for Fourier series. Actually, the Parseval's theorem or identity, Parseval's identity or Parseval's formula, same words. So we have to prove this and apply in an example. So first of all, the statement of the Parseval's theorem, if y equals to f of x is expanded as a Fourier series given by this is the formula for Fourier series, f of x equals to n naught by 2 plus n equals to 1 to infinity n cos n pi x by c plus bn sin n pi x by c, then minus c2 plus c f of x whole square, that means multiple of 2 times f of x multiply f of x. So f of x whole square integration range minus c2 plus c equals to c into c must, you must know length of the period, uh, second bracket half n naught square, that means cos coefficient for n equals to 0 plus summation n equals to 1 to infinity n square plus bn square. That means this is the formula which is called Parseval's formula or Parseval's identity. Okay, and f of x is the actually Fourier series. Now we'll try to prove this identity. Now proof. We know from Fourier series f of x equals to n naught by 2 plus n equals to 1 to infinity n cos n pi x by c plus bn sin n pi x by c. Actually, n is the cos coefficient and bn is the sine coefficient. Suppose this is equation number 1. Now multiplying by f of x in 1. That means in the equation 1, just multiplying by f of x on both sides, we get f of x whole square n naught by 2 f of x plus summation n equals to 1 to infinity n f of x cos n pi x by c plus summation n equals to infinity bn f of x sin n pi x by c. So from equation, just multiplying by f of x on both sides. This is equation number 2. Equation number 2. Now integrating term by term within limit minus c2 plus c. We get minus C2 plus C f of x whole square equals to a naught by 2 minus C2 plus C f of x dx. You have to use dx here plus summation an 1 to infinity an integral limit minus C2 plus C f of x cos n pi x by C dx. Again, n equals to 1 to infinity bn integral limit minus C2 plus C f of x sine n pi x by C dx. So this is equation number 3. Okay, now after this line, you can write this equals to R minus C2 plus C f of x dx equals to a naught by 2. This is the actually formula for Fourier series in the change of interval and function having arbitrary period. The previous section. That means we can write a naught C for this. A naught into C and summation n equals to 1 to infinity an, and this is the formula for what? C into an. C into an plus summation n equals to 1 to infinity bn, and this is the formula for what? C into bn. Since for change of interval in arbitrary period, you must know from minus C2 plus C f of x equals to C into a naught and minus C2 plus C and sine and pi x divided by C equals to C into bn. Okay. Therefore, hence minus C2 plus C f of x whole square dx equals to C into a naught square by 2 plus 1 to infinity n square plus bn square. This is the proved. Just putting the formula, we get the proof. Actually, we have used here a formula. You must know this formula. change of interval and function having arbitrary period, you must know a naught equals to what? 1 by c, 0 to twice c, f of x dx equals to this. That means 0 to twice c means what? Minus c to plus c. Okay, f of x dx equals to what will be a naught c. Okay, similarly, n equals to what? 1 by c, 0 to twice c, f of x cos and pi x by c. That means what? 0 to twice c means what? Minus c to plus c, f of x cos and pi x by c equals to n into c. Okay, similarly, bn equals to 1 by c, just using this formula, these three formulas. Okay, for cos coefficient for n equals to 0, and cos coefficient for arbitrary n, and for sine coefficient arbitrary. So using these three formula, we can prove the Parseval theorem or Parseval's identity or Parseval's formula. Now, an example, just using the Parseval's theorem, we can solve these types of problems. Find the Fourier series of y equals to x square if minus pi less than x less than pi. That means x lies between minus pi to plus pi. Hence, show that pi to the power 4 by 90 equals to 1 by 1 4 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 plus dot dot. So this is an infinite series. We have to show this series. So the given, we are given actually given function y equals to x square and minus pi to less x less than pi, which is even or odd function, which is what? Even function. Okay, you remember this. This is the even function. So for this, the Fourier series is given by f of x equals to a naught by 2 plus summation n equals to 1 to infinity n cos because sine will be omitted. Remember it. Okay, because this is the actually which function? Even function. This is why sine will be omitted for even function. Since even function, remember it, for even function sine term will be cancelled. So therefore a naught equals to what will be the formula for this? You must know 2 by pi, because pi is the actually domain, minus pi to plus pi, 0 to pi integral limit 0 to pi f of x dx. Okay, but f of x equals to what? 0 to pi remember this, for this 2 multiplication we can write we cannot write minus pi to plus pi, but the range will be minus pi to plus pi. We can write also this, but 2 will be absent for this. So if we multiply it by 2, then we can write this limit 0 to pi by using the properties of definite integral. F of x equals to what? X square dx. So this is the very easy integration, x cube by 3 integration and 0 to pi. So 2 by pi multiply pi cube by what? 3. This equals to what will be? Twice pi by 3, right? Twice pi by 3. And n equals to what will be? N equals to what will be the formula? 1 by pi minus pi 2 plus pi an cos what will be? Cos nx, right? Cos nx dx. So it can be written as twice by pi. Uh, sorry, there will be f of x, not n. This will be f of x. So 0 to pi, f of x means what? Nx dx. You must know this is the integration of product of two function. That means UV process. So we have to apply the UV process formula. How we can apply? First of all, u into integration of cos what? Sin nx, but dividing with the coefficient of x, minus differentiation of x square what? Twice x, differentiation of x square twice x, then again integration of this. Integration will be what? Minus cos nx divided by again divided by coefficient of x. So this become n square plus. Now differentiation of twice x what will be? Only 2. So again integration of this what will be? Cos integration what? Sin nx again dividing with the coefficient of n. So there are 3n multiplied. So n cube, and range will be what? 0 to pi. Lower limit and upper limit 0 to pi respectively. So n equals to what? Just to now using pi, the sin pi means what? 0. Sin n pi means 0. And using putting the below of upper limit and this also 0, just we get this minus minus what will be? Plus 2 cos n pi divided by what? N square. N square. Again putting value, this will also 0 and this also 0 and this also 0. So we get only what? This value. So 2 to 4 divided by 4 cos n pi divided by what? Divided by n square pi. Sorry, there will be pi, another pi here, twice pi. So pi will be cancelled. Okay, so we get only 4 cos n pi divided by n square. You must know cos n pi equals to formula what? Minus 1 to the power n. So this is the value we get. N equals to what? 4 minus 1 to the power n divided by n square. Again, the Fourier series of f of x. So the Fourier series of, so the Fourier series of f of x is what will be? F of x equals to n not equals to what? N not equals to just from this given, from this formula, from equation 1, n naught by 2 means what? 2 pi by 3 by 2. That means we get what? 2 will be cancelled. So only we get only this will be pi square. Remember it, pi square by what? 3 plus and just putting the value of n, we get 4 summation minus 1 to the power n by n square cos nx. This is formula 2. Just putting all the values of n0 and that means cos coefficients in equation 1. Now by Parseval's identity, we know by Parseval's identity or theorem, we know what actually f of x whole square equals to from Parseval's identity and integral limit will be what? 0 to minus pi to plus pi. The dx equals to what will be? Equals to n0 by 2 n0 square by 4 plus 1 by 2 summation n equals to 1 to infinity summation to infinity n square plus bn square. This is the actually formula of Parseval's theorem or Parseval's formula, etc. So here actually n not equals to what? 2 pi square by 3 and n equals to what? 4 into minus 1 to the power n by n square, and bn equals to what? 0, because this is the given function is even function. This is why we can write this. So from equation 3, we can putting these values from equation 3 minus pi to plus pi f of x equals to what? X square whole square dx equals to what will be? N naught square by 4 n naught square by 4 equals to what? N naught square by 4, because n naught equals to what? 2 pi square by 3. 2 pi square by 3 whole square divided by 4 plus half summation 1 to infinity n means what? 4 minus 1 16 minus 1 to the power twice n divided by what will be? N to the power 4. Or this is also even function, remember it. So from this we can write 2 divided by pi 0 to plus pi x to the power 4 dx equals to can write 4 will be cancelled. So 5 to the power 4 by 9 half 16 by 2 we can write 16 by 2 summation n equals to 1 to infinity minus 1 to the power twice n divided by n to the power 4. You must know twice n is the even number. So minus 1 to the power even number will be what? Always 1. So we can write 1 by n to the power 4. So or we get 2 will be cancelled 1 by pi. That means pi to the power 5 by 5. Just integrating, we get this equals to pi to the power 4 by 9 plus 8, and this will be what? Only summation 1 by n 4. So from this will be 5 4 divided by 5. So 5 4 divided by, to get this we can easily get that 8 1 by n to the power 4 equals to 5 to the power 9, sorry, 5 to the power 4 by 5 minus 5 to the power 4 by 9. Therefore, we get the series easily, which is equals to 4 pi 4. This equals to what? 4 pi 4 divided by 4. Thus taking LCM, we get this one. Hence, this series equals to this. Now, dividing by 8 on both sides, we get this pi to the power 4 by 90 equals to summation 1 by n to the power 4. So for every n, we can write 1 by 1 to the power 4 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 plus dot dot. This is actually required series for us. Okay, another example, example 2, prove that in 0 to x less than c, that means half range interval, x equals to c by 2 minus 4 c by pi square, third bracket 1 by 1 square cos pi x by c plus 1 by thrice square 3 square cos thrice pi x by c plus 1 by 5 square cos 5 pi x by c plus dot dot. So, and hence deduce that 1 by 2 minus 1 to the power minus 4 plus 3 to the power minus 4 plus 5 to the power minus 4 plus dot dot infinity equals to pi to the power 4 by 96. So for this, to finding this actually odd number, every integer, a positive integer is odd number. So sum of this will have to prove pi to the power 4 by 96. So you have to consider a function let y equals to x, and the interval will be what? 0 to what? C, which is actually odd or even function. Which one? Actually, this is odd function. So for Fourier series given by f of x equals to, because for the half range, we have to find the value of a naught, and we will get the bn equals to 0, because what? Half range. If this is actually not half range, then for this we get n equals to 0. Remember it. So f of x will be what? Same, n naught by 2 plus summation n equals to 1 to infinity and cos nx, since it is odd function in half range. Remember it, in half range. So n naught equals to what will be 1 by pi, 0 to what? 0 to 0 to what will be c. Okay. So n naught equals to 0 to c, and there will be actually 1 by 1 by c, according to the 2 by c, according to the formula for half range in the arbitrary period. So 2 by c and 0 to c x, formula what will be, value what will be, this integration just x square by 2. Okay, x square by 2, 0 to c and 2 by c. So we get 2 by c into c square by 4, and c will be cut, cancelled. We get actually, and 2 will be cancelled. This note will be 4. 2 will be cancelled. So we get only c. Remember it. So the cos coefficient for n equals to 0, we get what? Only c. Now n what will be? N will be similarly, formula what will be? 2 by c, 0 to c, f of x, n pi x by what will be? C, because for half range, remember it, for half range, the we have to use this formula. So 2 by c, f of x equals to what? S x, 0 to c cos n pi x by c, for half range 0 to c. Remember it. So twice c, just we have to using UB process of integration, product of two functions. So we get x into cos integration what? Sine n pi x by c, dividing with the coefficient of what? X, n pi by c, minus differentiation of x what? 1, again integration of sine minus cos n pi x by c. So we get n pi by c, how square here. Integral limit will be what? 0 to c. So for this value, what will we get? If we put x equals to c here, c will be cancelled. So sin n pi will be what? 0. Sin n pi will be 0. So we get only these values, and 0 for 0 also this will be 0, and we get only cos 0 equals to what? Cos 0 equals to what? You know, cos 0 equals to 1. So for this we can write 2 by c, just minus minus plus, we can write this will be in reverse, c square by n square pi square cos n pi, minus what will be, putting 0 minus 1. So we get this one values. So there are two values. So n equals to what will be? There are actually two values depending on n. For n is odd, we get a values, and for n is even, we get another values. Remember it, cos n phi equals to minus 1 to the power n. Okay. So depending on odd or even, n equals to, we get two values. One is minus 4c divided by n square pi square if n is odd. Okay. And another value 0 if n is even. So the Fourier series of f of x will be what? That means for the given function, we get just putting the values of a naught and n in equation 1. So we get what? A naught by 2 means what? C by 2. Okay. So another part will be minus 4L by pi square minus 4L by 4C by pi square bracket 1 by n square. That means there are another 1 by n square, this n square minus, sorry, summation. There will be summation because summation 1 by n square, n equals to 1 to infinity, cos n pi x by c. This is equation number 2. Okay. Now by Parseval's theorem, you can write this one. You must know this is equation number what? 3. Remember it, bn equals to 0. So we got what? N not equals to what? N not equals to only c. And n equals to what? N equals to what? This values. So putting here, putting a naught, a n, and bn equals to 0, because for this odd function and for the half range we got bn equals to 0. Remember it in equation number 3. So this will be, limit will be what? 0 to what? C, and function will be only x dx. So to c only x whole square, then what? C square by 4. This c square by 4 plus half n square, what will be? Summation n equals to 1 to infinity, n equals to this one. So we can write 8c square, 8c square by pi to the power 4. Pi square whole square means what? Pi to the power 4, and summation will be what? Odd. N will be here odd. So odd number will be twice n minus 1 whole square. Okay, and n equals to 1 to infinity. For every n, we get odd number in where? Here n square. So n square whole square means what? N to the power 4. For every even, we get 0. This is why omitting these values. We get only odd series for this. So this formula, what will be x square by or x square by 2, 0 to c equals to c square by 4 plus half. So integration will be what? X cube by 3. X cube by 3, and we get what totally? C cube by 3. And here 1 by another c. So c will be cancelled. So we get only c square by 3. Therefore, c square by 3 equals to, and c square minus 4 minus c square 4 equals to half summation 8 by 5 to the power 4, 8 by 5 to the power 4, 1 by 1 to the power 4 plus 1 by 2 to the power 3 to the power 4 plus 1 by 5 to the power 4 dot dot. What will be another c square here, and c square will be cancelled. This is why we can write 1 by 12 equals to 8 by 5 to the power 4, 1 by 1 to the power 4, 1 by 3 to the power 4, 1 by 5 to the power 4 plus dot dot. Hence, okay, now another important example for you. Example 3. By using sine series, that means for Fourier series, Fourier sine series for unity. Okay, the function will be f of x equals to 1 in the intervals 0 to pi. That means x lies between 0 to pi. Then we have to show that this series n equals to 1 to infinity, 1 by twice n minus 1 whole square equals to pi square by 8. So we have to consider a function for this. We have to, because for unity here we can write f of x equals to what? 1, and the limit range domain will be 0 less than x less than pi. So the Fourier sine series, so the Fourier Fourier sine series for f of x is given by f of x equals to a naught will be 0 and n also 0. So we get only n equals to 1 to infinity bn sine nx. Okay. Now first of all we have to find the bn for this. So this is equation number 1. Now bn equals to, what's the formula you must know? Bn equals to what will be? Formula 2 divided by pi 0 to pi f of x sine nx dx. 2 by pi 0 to pi f of x equals to what? Only 1 nx dx. So sine nx, so the sine nx will be formula what? Sine formula what? Minus cos nx divided by n. And limit will be what? 0 to pi. Okay, there is a minus, negative sign. So now putting the upper limit and lower limit, we get this is the pi. This equals to minus 2 by n pi cos n pi minus 1. Therefore, bn equals to what will be? Bn equals to 1 minus 2 by n pi 1 minus minus 1 to the power n, because cos n pi equals to minus 1 to the power n. So depending on n, whether it is odd or even, we get two values for that. That means bn equals to what will be? There are two values. One will be if n equals to 1, then you get 1 plus 1. That means 2. So 4 by n pi. If n is odd, and 0 if n is even. So there are two values of bn. So from equation 1, f of x what will be? Just putting these values, we get 4 by pi 1 by n, 1 by 1 into, that means sin x by 1 plus sin thrice x by 3 sin 5x by 5 plus dot dot. So we get only even only odd terms. So by Parseval's identity, Parseval's theorem or identity, which we have proved already in this class, what will be?
তো একটা মাইনাস মিস্টেক হয়েছে মেবি bn equals to minus 2 by n pi মাইনাসটা মিস করেছেন সম্ভবত
Yes, no, one this one before in the before this cos n pi. This is why minus minus will be cancelled. Okay, cos n pi minus 1, but we have written 1 minus cos n pi. Okay, minus minus will be cancelled.
Okay sir, okay.
So by Parseval's theorem, we get what? actually 0 to 0 to pi f of x whole square dx. What will be? Because a not equals to 0 and n equals to 0, so we get obviously the bn terms only. N equals to 1 to infinity bn whole square. Okay, since what a not equals to 0 and n equals to 0, because we are finding only for sine series. Remember it, for sine series this will be cos coefficient will be 0, or 1 by pi 0 to pi 0 to pi f of x means only 1. Okay, dx. This equals to half summation n equals to 1 to infinity bn square means what? 4 square by, that means 4 square means what? 16. So 16 by pi square will be common from every term. So for n is odd, 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot dot. Or actually this integration will be, you get only one summation n equals to 1 to infinity 16 by pi square. Actually this means what? This is the actually odd number of series. Odd number of series, that means 1 by twice n minus 1 whole square. So actually 16 and 2 will be cancelled from both sides. So we get here, or 1 equals to 8 by pi square equals to 8, sorry, into summation n equals to 1 to infinity 1 by twice n minus 1 whole square. Hence the required result, summation n equals to 1 to infinity 1 by twice n minus 1 whole square equals to pi square by 8. Short. Very easy result just by using Parseval's identity. Very easy result.
স্যার আপনার জন্য একটা স্লট বের করতে পেরেছি সোমবার দিন।
সোমবারে তো আমি ব্যস্ত থাকি, আমি সোমবার ব্যস্ত থাকি তো। Okay, this example by using time series for y equals to x in the interval 0 to less than x less than l, you have to show this series. That means for n equals to 1 to infinity 1 by n square 1 by n square equals to what will be? Pi square by 6. So for the given function f of x equals to x, 0 to x lies between 0 to l. So the Fourier series for f of x is given by this one. This is the equation number 1. And similarly, bn equals to what will be? Twice by l, 0 to l f of x sin n pi x by l dx. This is the formula. And a naught and cos coefficient a naught and n will be 0 because sin series. So twice by l, 0 to f of x equals to x sin n pi x by l. Just using UV process, we get these values. So bn values what will be here? After putting L, here L will be L into something, and LL will be cancelled, so cos n pi we get. And this will be LL, and sin n pi will be 0. And for 0, whole are 0. So we get only one term from here. Okay, 3 term will be cancelled. So we get only 2 by L, 2 by L. We just putting L here, putting L minus L square by n pi, minus L square by n pi cos n pi. Only this term. All term will be 0. So this equals to LL will be cancelled, twice L divided by n pi, cos n pi equals to what? Minus 1 to the power n, and another minus 1. This is why minus 1 to the power what will be n plus 1. Understand everybody? Since cos n pi equals to what? Minus 1 to the power n. Remember it. So from equation 1, just putting these values, we get what? F of x equals to what will be? F of x equals to twice L by pi, and will be n equals to 1 to infinity, minus 1 to n plus 1 divided by n, and sine n pi x by L. Okay. So this is a series depending on different values of n. So by Parseval's identity, we can write this will be the 1 by L f of x whole square. It will be only summation bn square, since n not equals to 0 and n equals to 0 for the sine series. So we get 1 by L f of x equals to what? Only x, and limit will be what? 0 to L. So we get what? L cube by 3. Okay. So L cube by 3 means what? LL will be cancelled. So L square by what? 3. And Bn square equals to means what? Putting these values, twice L by 2.5, 2 will be cancelled. So just putting, we get L by 5 minus 1 to the power n plus 1 divided by n sine n pi h by L. So L square by 3 to L square by pi square. To L square by multiplying by L on both sides, L square by pi for different values of n. This will be summation 1 by n square. So L square will be cancelled from both sides. So we get summation 1 by n square equals to pi square by 6. This is actually required result. But this series can be written as depending on n equals to 1, 2, 3, etc. we get this series 1 by n square. Okay, for n equals to 1, this will be for n equals to n sin n pi. Sin n pi will be 0. Okay, for n equals to 2, n equals to 2, we get minus 1 to the power what? This will be n square, remember it, n square. For n equals to 2, for n equals to 3, n equals to 4, we get this series, remember it. So this is the actually short result. So very easy for you. Understand everybody? Hello. Now I am giving you two homeworks for you. Just using Parseval's identity, you can solve this one. This 20 will be homework for you. By using the sine series of x equals to 1, I have x equals to 1 and x lies between 0 to pi. Okay. So this is a similar example we have solved today. Okay. So this 20 will be homework for you. And pi square 8 by 1 by 1 by 3 square plus 1 by 5 square 1 by 7 square. Similar example. 21 also homework for you. If f of x equals to pi x, where x lies between 0 to 1, and pi into 2 minus x, where x lies between 1 to 2. That means piecewise function. For this piecewise function, we have to use half range cosine series. Cosine series means what? Sine coefficient will be 0 for that. So for that, Fourier series will be this for cosine series. A naught equals to similarly similar formula using, and n equals to this one 0 to 1 and 1 to 2, then we get the result. Okay, and this 22 also. Okay, prove that this series and deduce a and b using this half range cosine series. Similar process by using Parseval's identity. Okay, so this will be homework for you. Thanks to everybody. Bye for today.